All right, let's talk about something we use every single second we're online, but maybe don't really think about: the OSI model. Sounds complicated, right? Well, we're going to break it down by thinking of the internet as a giant, super efficient post office. Seriously, have you ever stopped to think about it? You hit send on an email in New York, and poof, it appears on a screen in Tokyo almost instantly. How on earth does that actually work? It feels like magic, but I promise you, it's not. It's just a really, really well-organized system. And that system, well, it works a lot like the good old post office. Sending data across the internet is surprisingly similar to mailing a physical letter. There are specific steps for writing it, addressing it, sorting it, and getting it delivered. That whole rulebook, that's what we call the OSI model. It's basically the internet's postal service. So to understand this, we're going to start our journey right at the top. I mean, right where you are, the user. We'll look at the layers that are all about creating the message in the first place. Kind of like sitting down with a pen and paper to write a letter. First up, layer 7, the application layer. And the analogy here is super simple. It's you. It's your web browser, your email client, whatever app you're using. This is the part you actually see and interact with. When you decide to type in a web address or start a new email, you're the letter writer. You're creating the stuff that needs to be sent. Okay, so once you've written your letter, we hit layer 6, the presentation layer. You can think of this as a super smart editor or maybe a translator. Before your message goes out, this layer makes sure it's in the right format. It handles things like encryption, kind of like putting it in a secure envelope, and compression, folding it up neatly so it takes up less space. It's all about making sure the computer on the other end can actually read and understand what you sent. And the last of our top layers is layer 5, the session layer. I like to call this one the call coordinator. It's the part that metaphorically picks up the phone and says, "Hey, you there? Let's open a line." It sets up the conversation between the two computers, keeps that connection stable while you're talking, and then hangs up properly when you're done. It manages that whole back and forth session. All right, so our digital letter is written, it's formatted, and we've got an open line. But now, how does it actually get where it's going? This is where we get into the logistics layers. This is the nitty-gritty of packaging and shipping. And that brings us to layer 4, the transport layer. This is your delivery driver. Its main job is to take your whole message, chop it up into smaller, more manageable packages if needed, and then decide how to send them. And it's got two totally different ways of doing that: TCP and UDP. So you've got two options here. First, there's TCP. Think of TCP as registered mail. It's super reliable, it gets a signature, checks that every single package arrived in the right order, and if anything gets lost, it sends a replacement. This is what you use for things like email or loading a web page, where every piece has to be perfect. On the other hand, you have UDP. UDP is like a postcard. You just write it and send it. It's way faster, but there's no guarantee it'll get there. This is perfect for stuff like video calls or online gaming, where a dropped frame here or there isn't a big deal, but speed is everything. Diving deeper, we get to layer 3, the network layer. Now, this is the giant worldwide postal sorting facility. This is where the magic of the internet really happens. It looks at the big final destination address, the IP address, and figures out the absolute best route for your data to take across dozens of different networks to get where it's going. All those routers out there, they're the master sorters working at this layer. Okay, so our package has made it across the world to the right city, maybe even the right neighborhood. But now we have to get it to the right specific building, the right apartment. That's the job of layer 2, the data link layer. Think of it as the mailroom in your building. It uses a very local address, called a MAC address, to make sure the data goes from your local Wi-Fi router directly to your laptop and not the one next door. And at the very bottom, we finally hit layer 1, the physical layer. This is the stuff you can actually, touch and see. This is the infrastructure, the trucks, the roads, the airplanes of our postal service. For the internet, we're talking about the actual physical Ethernet cables, the fiber optic lines glowing with light, the Wi-Fi signals flying through the air. This is where our digital bits and bytes become real physical signals. Okay, so we've looked at all the individual players in this system. Now let's do a play-by-play. Let's trace a single, simple request from your browser all the way to Google's front door and back again. So check this out. You type google.com and hit enter. That's layer 7. Instantly, your request starts its journey down the stack. Layer 6 formats it. Layer 5 opens the session. Layer 4 chops it up and picks TCP for reliability. Layer 3 slaps on Google's IP address. Layer 2 adds the local address for your router. And finally, layer 1 turns it all into signals.
Each step wraps the data in another digital envelope. It's like a Russian nesting doll. Then, when it gets to Google, the whole process happens in reverse. They unwrap each layer, read your request, and send the web page back to you, doing the exact same wrapping process all over again.
I know this might sound super abstract, like, who cares, right? But trust me, understanding this isn't just for hardcore network engineers. It's actually one of the most practical tools you can have for figuring out why your tech is acting up.
Because what the OSI model really gives you is a map. It's a troubleshooting checklist. When something goes wrong, you can mentally go down this list from the application you're using all the way down to the physical wire and figure out where the breakdown is.
So why should you care? Because the next time your internet goes out, you can think like a pro. Is your Wi-Fi icon just gone? Hey, that's a layer 1 problem. Is the cable plugged in? Did you pay the bill? Can you get to Google just fine but not, say, Netflix? Well, that sounds like a layer 7 problem. It's probably an issue with Netflix's app, not your whole internet connection. See? This model is literally the backbone of how we diagnose network issues, and it's the foundation for pretty much every networking certification out there. So I'll just leave you with this thought. The next time you're trying to watch a movie and that dreaded buffering wheel starts spinning, or a website just won't load, which layer of this whole digital postal service are you going to think of first? Because now you've got the map to start figuring it out. Thanks for joining me on this one.